This is Dr. Shankaraiah from Department of Physics. In this presentation, I am going to discuss the definition and terminology on module by nanotechnology. First question is, what is meant by nanoscience? Nanoscience deals with the scientific study of objects with a size in the range of 1 to 100 nanometers, at least in one dimension. So, at least in one dimension, we should have this nanoscale ranging from 1 to 100 nanometers. Then, the science that deals with these materials are called nanoscience. Define nanotechnology. Nanotechnology is a design, characterization, production, and application of structures, devices, and systems by controlling size and shape at nanometer scale. Basically, in nanoscale. So, that is around 100 nanometers to 0.2 nanometers. So, we are just roughly defining here as 1 to 100 nanometers. What is nanoscale? Nanoscale is usually refers to structures with a length scale applicable to nanotechnology, usually cited as 1 to 100 nanometers, or as I mentioned, 100 nanometers, 0.2 nanometers to 100 nanometers. So, this is called as nanoscale. What is nanomaterial? The processing grains of size ranging from 1 to 100 nanometer is known as nanomaterials. The nanomaterials can be produced with different dimensionalities. You can have in one dimension, you have nanoscale, 2 dimension, 3 dimension. Different dimensions, you can have nanoscales. What does nanotube mean? A nanotube is a material that has a tube-like structure, and nanotechnology, which is a relatively recent field with much potential as well as some significant liabilities. So, that is nanotube. What are carbon nanotubes? Nanotubes are members of the fullerene structural family, which also includes buckyballs. Carbon nanotubes are allotropes of carbon with a cylindrical nanostructures. Those are called as carbon nanotubes. What is nanowires used for? Nanowires are extensively used in nanoelectronic devices such as silicon, gold, have been utilized to make nanowires. Chemical vapor deposition is used for the production of nanowires. Describe quantum confinement. When the length of a semiconductor is reduced to the same order as the exciton radius to a few nanometers, quantum confinement effect occurs and the exciton properties are modified. Depending on the dimension of the confinement, 3 kinds of confined structures are defined: quantum well, quantum wires, and quantum dot. So, quantum well is one dimension. So, quantum well is one dimension, and quantum wire is 2 dimension, and quantum dot is a 3-dimension structure. So, that is quantum confinement in 1 dimension, 2 dimension, and 3 dimensions. What is meant by surface to volume ratio? The surface area to volume ratio of an object is a relationship between 2 measurements. It is a ratio of surface area to volume. It shows the comparison between the size of the outside of an object and the amount of inside. Small or thin objects have a small surface area to volume ratio. For example, if we take a sphere, spherical object, spherical particle, for example, so radius of the spherical particle is r, and surface area to volume ratio for this will be 3 by r. Okay, so if we calculate surface area to, because surface area is 4 pi r square and volume for this spherical one is 4 by 3 pi r cube. So things cancel out here, you will get 3 by r. Okay, so this is surface area to volume ratio for a spherical particle. So if you reduce the size to 1 by 2, if you make it r by 2, then r will become r by 2, it will become 6 by r. So if you reduce the size of the particle, the surface area to volume ratio increases. Okay, so size, surface area to volume ratio. Size decrease, surface area to volume ratio increases. Size increases, surface area to volume ratio decreases. Okay, so it is inversely proportional. So what is the purpose of sol-gel method? Sol-gel technology is a well-established colloidal chemical technology which offers possibility to produce various materials with novel predefined properties in a simple process and at relatively low process cost. Okay. So using sol-gel method, we can prepare various materials which are with predefined properties. Explain different approaches used in fabrication of nanomaterials. There are two approaches for the manufacturing of nanomaterials. The top-down approach, which involves the breaking down of large pieces of materials to generate the required nanostructures from them, top-down approach, and bottom-up approach, which employs assembling single atoms and molecules into large nanostructures. Write about the chemical vapor deposition method. Chemical vapor deposition is a process that involves the reaction of a volatile precursor which is injected into a chamber, typically on vacuum. The chamber is heated to a reaction temperature that causes the precursor gas to react or break down into desired coating and bond onto the material surface. What is physical vapor deposition? Physical vapor deposition is a process in which matter is vaporized from a solid or liquid source and transported as vapor through vacuum or low pressure gaseous environment and condensed onto a substrate. What is ball milling? Small hard balls, stainless steel balls are allowed to rotate inside a container, and then it is made to fall on a solid with a high force to crush the solid into nanocrystal. You have a drum, rotating drum, and this drum is made to rotate, and you have stainless steel balls, okay, and you have a material here, okay. So when you rotate this drum, these balls will fall onto this material, okay, and then these balls, stainless steel balls, will crush the material whatever you have inside. So that is ball milling, or we also call this ball milling as mechanical crushing. When the container is rotating around the central axis, the material is forced to press against the balls. The milling balls impart energy on collision and produce smaller grains of nanoparticles around 10 to 30 nanometers. What is X-ray diffraction used for? X-ray diffraction is used for the primary characterization of material properties like crystal structure, crystallite size, and strain. So, the use of XRD in pharmaceutical research is extensively increasing due to its wide application. So, you can use XRD to characterize whether the material is a crystal or amorphous. The non-crystalline materials are called amorphous. So, you can use this XRD diffraction, technique to characterize whether the given material is crystalline in nature or amorphous in nature. This is the primary application. What is a TEM? A transmission electron microscopes are microscopes that use a particle beam of electrons to visualize specimens and generate a highly magnified image. TEMs can magnify objects up to 2 million times. What are the applications of nanomaterials in agriculture? Nanotechnology can increase agricultural production and its applications into nano formulations of agrochemicals for applying pesticides and fertilizers for crop improvement. The application of nanosensor in crop protection for the identification of diseases and residues of agrochemicals. So these are the applications of nanotechnology, nanomaterials in agriculture. What are examples of nanoparticles in food? For example, silicon dioxide is added to salts, spices and icing sugar to improve their flow. Salt and green tea are ground to nano-sized particles to boost their flavor or to improve their antioxidant properties. Titanium dioxide or TiO2, titanium oxide, appears in sweets, baked goods and milk powders often as a whitening agent. These are the applications of nanoparticles in food. What are applications of carbon nanotubes in medicine? Carbon nanotubes are used in drug delivery and cancer therapy, selective cancer cell destruction, tumor targeting, glucose detection, biosensor, etc. So we use CNTs in various therapies and glucose detection, biosensor in medicine. What is meant by bottom-up method? Bottom-up method involved assembly of atoms or molecules into nanostructured arrays. In this method, the raw material sources can be in the form of gases, liquids, or solids. It is of two categories, chaotic and controlled processes. What is the scope of nanotechnology? Nanotechnology is one of the fastest developing fields with potential to revolutionize industries such as pharmaceuticals, electronics, military, manufacturing, and agriculture. What are the applications of nanomaterials in biotechnology? Nanobiotechnology is best described as helping modern medicine progress from treating symptoms to generating cures and regenerating biological issues. So we use nanomaterials in biotechnology to progress in various treating symptoms to generating cures. What are the applications of nanomaterials in medicine? The applications of nanomaterials in medicine are nanocrystals as fluorescent biological labels, magnetic nanoparticles, tissue engineering, DNA chips, detection of chemical and biological warfare agents. What are the applications of nanomaterials in information and communication? The applications of nanomaterials in information and communication are memory storage, novel semiconductor devices, novel optoelectronic devices, displays, and quantum computers. What is the example of top-down process? The example of top-down technique for fabrication is lithography, in which instruments are used to scale a macroscopic plant to the nanoscale. What are the applications of nanomaterials in industry? The applications of nanomaterials in heavy industry are aerospace, catalysis, construction, vehicle manufacturers. What are the 4 types of nanomaterials? There are 4 main types of intentionally produced nanomaterials: carbon-based, metal-based, dendramides, and nanocomposites. What is the basic concept of nanotechnology? Nanotechnology mainly consists of the processing of separation, consolidation, and deformation of materials by one atom or one molecule. Who invented nanotechnology? The American physicist and Nobel Prize laureate Richard Feynman introduced the concept of nanotechnology in 1959. Richard Feynman. What is the principle of ball milling method? The working principle is impact and addition size reduction take place as a ball drops from near the top of a rotating hollow cylindrical shell. What does CVD stands for? Nanoparticles. Chemical vapor deposition technique of depositing material as a thin film onto substrate from vapor spaces through chemical reactions. What is a chemical vapor deposition method for the synthesis of nanotubes? Catalysis chemical vapor deposition methodology for carbon. In CVD method, it has used a gaseous phase hydrocarbon to pass through a tube-shaped reactor in the presence of various catalysts at 500 to 1000 degree to form carbon nanotubes. What are the applications of vapor deposition? Physical vapor deposition is used in the manufacture of a wide range of goods, including semiconductor devices, aluminized PET, film for balloons and snack bags, optical coatings and filters, coated cutting tools for metalworking, and wear resistance and highly reflective films for decorative displays. What is PVD, physical vapor deposition in nanotechnology? So, physical vapor deposition is a technique used to deposit a thin layer of material on a substrate surface in the presence of a vacuum. What is the scope of nanotechnology? Nanotechnology is one of the fastest developing fields with potential to revolutionize industries such as pharmaceuticals, electronics, military, manufacturing, and agriculture. What is the thickness of chemical vapor deposition? The average thickness of our various chemical vapor deposition coatings is around 5 to 10 microns. What is the principle of transmission electron microscopy? The basic principle of transmission electron microscopy is that a photographic image is recorded from the electronic flux after it has passed through a thin sample of the specimen under study. So we actually get photographic image when the electron pass through the material, nanomaterial. So there can be scattering, elastic, inelastic scattering and all. What are the advantages of TEM? The TEM has the added advantage of greater resolution. This increased resolution allows us to study ultrastructure of organelles, viruses, and macromolecules. We can study various viruses, macromolecules, and organelles using this transmission electron microscopy, which provide us high magnification. What is the X-ray diffraction? An X-ray diffraction is the result of constructive interference between X-rays and a crystalline sample. Right? So, because of the constructive interference between X-rays and crystalline sample, we get this diffraction pattern. Mention the types of PVD in nanotechnology. So, there are various physical vapor deposition techniques available, including sputtering, ion plating, magneton sputtering, and electron beam sputtering. So, these are some of the available approaches in physical vapor deposition technique in nanotechnology. So, these are the 40 definition and module 5 nanotechnology. I've discussed. So, to summarize, I have discussed the definition and terminology and module 5, which is nanotechnology. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.